physics for class 11, and that is very important one. And this is your class 33. We had done your 32th class in the last session, where we had completed the unit 4 that been completed, which is of course been the important one, so you will have to go for the same. And the remaining questions as well I had discussed about it. If you have any doubt regarding that, you can just contact me, and then I will be surely help you out for the same. Now coming towards laws of motions, this is your unit 5 in the first class of unit 5, laws of motion. So in laws of motion, if I am going ahead in the detail about it, before starting with the same, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and another you can also enjoy the video as well. In laws of motion, that is in a preceding chapter, that one concern was to describe the motion of a particular in space quantitatively. We saw that a uniform motion that need the concept of velocity alone, where non-uniform motion requires a concept of acceleration in addition. So far we have not asked the question as to what governs to the motions of bodies. In this chapter we turn to these basic questions. Okay, on the same way, let us first discuss the answer that is based on our common experiences, and that is, to move a football at rest, someone must kick it. To throw a stone upward, one has to give it an upward push. A breeze causes the branches of the trees to swing, and a strong wind that can even move heavily object. A boat moves in a following river without anyone rowing it. Clearly, some external agencies is needed to provide force to move a body from rest. Likewise, an external force is needed and also to retard or stop motion. You can stop a ball rolling down an inclined plane by applying a force against the directions of its motion there. And in these examples, the external agency of a force, that hands, wind, stream, etc., is in contact with the object. This is not always necessary. A stone released from the top of the building that accelerates downward due to the gravitational pull, and that is the gravitational pull of earth, and a bar magnet that can attract an iron nail from a distance. This shows that the external agencies, example, your gravitational and magnetic force, that can exert force on a body even from a distance. So just this is the important point. I will just write it for you all. If you are making a note, you can just copy it down. So for the same, here we go on a detail about it. So this shows that external agencies example, gravitation and magnetic forces can extract force on a body even from a distance. Okay, in the same way, here in a shot of force is required, and that is to put a stationary body in a motion or stop a moving body, and some external agencies is needed to provide this force. The external agencies may or may not be in the contact with the body as well. In the same way, so far so good, but what if the body is moving uniformly? Example, a skater moving straight with constant speed on a horizontal ice slab, and is it that is an external force required to keep a body in a uniform motion? That is, the question is being arise. So what you will be saying in terms of it. In the same way, we'll discuss the Aristotle fallacy. वैसे ये NCERT बेसिस क्वेश्चन में बहुत इंपॉर्टेंट टॉपिक है, बट ज़्यादातर ये क्वेश्चन इस टाइप के इस ऑन द बेसिस ऑफ दिस क्वेश्चन इतने पूछे जाते नहीं हैं, बट क्योंकि ये NCERT का पार्ट है, सो आई विल डिस्कस दैट एज वेल. सो विल टॉक अबाउट फॉर द Aristotle fallacy. In terms of Aristotle fallacy, so here in the same way we'll discuss about it. For Aristotle fallacy, here in terms of that we discussed in a detail as I told you. So in Aristotle fallacy, that the question posed above appeared to be a simple, and however it took ages to answer it. Indeed, that the correct answer to this question that is given by the Galileo in the 17th century was the foundations of Newtonian mechanics, and which signed the birth of the modern science. The Greek thinker Aristotle in 384 BC to 322 BC held the view that if the body is moving, something external is required to keep it moving. According to this view, for example, an arrow shot from a bow keeps flying since the ear behind the arrow keeps pushing it. The view was part of an elaborate framework of ideas developed by Aristotle on the motion of bodies in the universe. Most of the Aristotelian ideas on motions are now known to be wrong and need not concern us. For our purpose here, the Aristotelian laws of motion that may be phrased, that is, the external force is required to keep a body in motion. That is, of course, if you want a body to be keep moving, so you have an you required an external force that is required to keep the body in a motion. So this is very important point that has been given by the Aristotle fallacy by Aristotle. This is a Greek thinker from in 1384 BC to 322 BC that has the held view. So an external force is required to keep a body in motion. Okay. In the same way here, for this that Aristotelian laws of motion is flawed, and as we see, however, it is natural view that anyone would hold from a common experience. Even a small child playing with a simple non-electric toy car on a floor knows intuitively that it needs a constantly dragged to string attached to the toy car with some forces to keep it going. If it releases the string, it comes to rest. The experience is common to most terrestrial motion. External forces, that is, the external forces seem to be needed to keep the bodies in motion. Left to themselves, all body eventually come to rest here. The same way, what is the flaw in Aristotle argument? The answer is, as a moving car comes to rest because the external force of frictions on the car, that of the floor, opposes its motion here. And to counter this force, the child has to apply an external force on the car in the direction of motion. When the car is in uniform motion, there is no net external force acting on it, and the force by the child cancels the force where friction by the floor here. Now the same way, the causality is, if there were no friction, the child will not be required to apply any forces to keep the toy car in a uniform motion. And the same way, the opposing forces such as friction, solids and viscous forces, that is for fluid, are always present in the natural world. And in the same way, this explains why forces by external agencies are necessary to overcome the frictional forces to keep bodies in uniform motion. Now we understand where Aristotle went wrong. He coded this practical experience in the form of a basic argument to get at a true law of nature for forces and motions. One has to imagine a world in which uniform motion is possible with no frictional forces, and that is no frictional forces opposing. This is what Galileo did here. Okay, so now we'll talk about the law of inertia. very important. ये एक ऐसा टॉपिक है जो लॉज ऑफ इनर्शिया है, ये आपका मैक्सिमम 99.5% आता है आपके बोर्ड एग्ज़ाम में. या तो ये टॉपिक पूछ लिया जाएगा या इसके रिलेटेड आपका क्या कहते हैं कुछ ना कुछ पूछ लिया जाएगा. कुछ ना कुछ से मतलब है कि लाइक न्यूमेरिकल पूछ लिया जाएगा या कॉन्सेप्ट से रिलेटेड क्वेश्चन दे दिया जाएगा. सो दिस इज़ वेरी इम्पोर्टेंट. तो अगर आप नोट्स बना रहे हो तो आई थिंक ये बहुत ही ज़्यादा इम्पोर्टेंट टॉपिक है, आप उसको कर लो सो दैट यू विल गेट टू नो अबाउट इट. नाउ कमिंग टूवर्ड्स लॉज ऑफ इनर्शिया हम डिटेल में पढ़ेंगे, उसके बाद न्यूटन्स फर्स्ट लॉ ऑफ मोशन भी पढ़ेंगे हम. बट उसके अलावा अगर हम बात करते हैं तो क्योंकि हम लोग एक आइडिया ऑफ मोशन इन एन एंशिएंट इंडियन साइंस के बारे में डिस्कस कर लेते हैं. फिर लॉज ऑफ इनर्शिया हम डिस्कस करेंगे कमिंग क्लास में, विच इज़ ऑफ योर 34th क्लास. So we'll discuss that there both the laws of inertia as well as Newton's first law of motions as well, because there are many motions that we have to discuss, the second laws and the third laws. So वो एक class में हो नहीं पाएगा. So let's get started with the ideas on motion in ancient Indian science. Okay, that we will be discussing. So here for that, in the same way here, ancient Indian thinker that had arrived at an elaborate system of ideas of motion force, that the cause of motion was thought to be a different kind. Force due to continuously pressures that is known as the force of wind on sailing vessels. Impact your abhighat, that is as when the potter's rod strikes the wheel. Persistent tendency, that is your sanskara, and on the way to move in a straight line, vega, or a restorations of shape in an elastic body. The transmitted force by a string, rod, etc. The notions of vega in the that is your Vaisesika theory of motion that perhaps comes closest to the concepts of inertia. Vega, the tendency to move in a straight line, was thought to resistance and it was correctly summarized that the different kinds of motion, translational, rotation, and vibrational, of an extended body that arise from only the translation motion on its constituent particles in a falling leaf in the wind that may have a downward motion as a whole pattern, and also the rotational definite small rotational and vibrant motion, which is your Brahman and Spandan, and but each particle of the leaf at an instant only has a definite small displacement. There was a considerably focus in Indian thought on measurement of motions and units of length and time. It was known that the positions of a particle in a space that can of instantaneous motion, which is that Kaliki Ghati, and when anticipated the most modern notions of instantaneous velocity using a differential calculus. The difference between a wave and a current of water was clearly understood, and a current is a motion of particles of water under the gravity and fluidity, while a wave results from the transmissions of vibration of water particles. Now we are going to end up with, I will discuss the law of inertia in the next coming class. This is your part 1 class 11 physics, where we had completed your 4 unit, which is unit physical world, units and measurements, motions in a straight line, and we are dealing with another one which is coming towards motion in a plane. We are dealing here. After that, we will be discussing unit 5 is the laws of motion. Unit 5th, we are dealing laws of motion. Unit 6 is your work, energy and power. Unit 7 is system of particles and rotational motion. Unit 8 is your gravitation. That all we have to cover up here one by one. So here, stay tuned with us, and please like, share and subscribe, so that many and maximum people can get the information at once, and maybe you can also enjoy the video as well. Thank you. Please like, share and subscribe.